Wanted to share this video with you, 2016 number 3. It's comparative advantage. We learned about this in Unit 1 way back at the beginning of school, or at least the school year, calendar year. So hopefully remember this. It's going to give you two items that are able to produce two goods. First thing you've got to identify is if it's an innie or an outie. Most likely it's going to be an output problem, but don't just assume that. So how do you determine? Well, it's all based on what do these numbers represent. Are these numbers talking about how much total stuff are they producing, in which case it's an output problem, or are they referring to the inputs, the factors that are needed to produce a similar item? In this case, we're talking about output. The following table shows the number of donuts or cupcakes that John and Erica can each production in a given day. That given day is their input. These numbers relate to outputs. And that's critical because in order to solve that, in order to know what the absolute advantage is, that's going to help us to know that it's an output problem. And we'll talk more about that. So A, who has the absolute advantage in the production of donuts? Well, if it's an output problem, you're just looking at who is able to produce more in the same amount of time with the same inputs. So John has an output A. John, my explanation should be he can produce 200, whereas Erica can only produce 150 given the one day. And I would probably give some figures in there like I just did verbally. So that's A, simple point. Who has the comparative advantage in producing donuts? Do not just assume that because John can produce more donuts, he has a comparative advantage in. Comparative advantage is what you are able to produce with the lowest cost. What you have a comparative advantage is what you should specialize and trade in. Well, how do you find that comparative advantage? Remember, you're looking for the per unit opportunity cost. In order to find the per unit opportunity cost for an output problem, the other goes over. So in order to find, once you've figured that it's an output problem, you need to find the per unit opportunity cost. What are you giving up by producing one of the given items? So one donut, what is the opportunity cost? How many cupcakes are you producing? So I like to set up one cupcake equals how many donuts. And please, please, please label it out, draw it out. On the AP test, it's just scrap notes that you can take. One cupcake equals how many donuts. Now, in order to find that, remember the other goes over. So the other goes over. In the time it takes John to produce one donut, the other goes over. He could have had a half a cupcake. This pen doesn't work. A half a cupcake. The other goes over. 200 over 100 gives me, in the time it takes John to make one cupcake, he could have made one or two donuts. Remember, if you're doing it right, 1/2, 2, those numbers should be reciprocals. I apologize if it's harder to see. I'm going to do it in black pen. It might be easier. Again, the other goes over. 50 over 150 equals 1/3. In the time it takes Erica to produce one donut, she could have had 1/3 cupcake. The other goes over. 150 over 50, 3 donuts. Okay. Once you've figured out the per unit opportunity cost for the given items, you're just going to look at the numbers, the opportunity costs, what we just figured out, and you circle who has the lowest production, who has the lowest number for the given item. So donuts, I'm looking in the donuts column. 1/3 is less than 1/2, and I circle that. Well, in cupcakes, look in the cupcake items. 2 is less than 3. I circle that. What I circle, that's who has the comparative advantage in that given product. That's who should specialize and solely just produce that given item. So question B asks, who has the comparative advantage in producing donuts? Well, donuts, it's Erica. My explanation that it's asking for should be that Erica can produce it at a lower opportunity cost compared to John. And I would give, again, the figures for that. Erica's opportunity cost is only 1/3 to produce it, where John's is a half, because Erica's opportunity cost is lower. She has a comparative advantage and should produce that. Assume that, question C, Assume that John and Erica decide to specialize to their comparative advantages and that one cupcake is exchanged for one donut. One cupcake for 4 donuts. Okay. I like that it's in per unit already, 1. So who's producing the one cupcake? Well, again, who has the comparative advantage? John. And I would write it out. John trades 1 cupcake for 4 donuts from Erica. Okay, well, let's just put this together intuitively. Okay, so in exchange for 1 cupcake, John is now getting 4 donuts. Well, let's look at it. Previously, if John decided to not produce 1 cupcake, how many donuts could he have had? 2. So now John is getting 4 donuts from that trade. So does John like the trade? Yes, hell yeah, John likes that trade. He gets twice as many donuts as he could otherwise. So John's a plus. Well, what about Erica? Well, Erica is giving up 4 donuts. Well, let's convert that 4 to be a 1. So 1 donut, how do we do that? We divide by 4, right? I want to get it in a single term, a per unit term. So now 1 donut that Erica is giving up in exchange for 1 donut, she's receiving 1/4 cupcake. Now, these are equivalent trades. 1 cupcake for 4 donuts is the same as 1/4 cupcake for 1 donut. It's just divided by 4 at the bottom here. But now because I have 1 donut here, I can easily compare to determine whether Erica likes it or not. Previously, if Erica just produced donuts and cupcakes on her own, in the time it took Erica to produce 1 donut, she could have had 1/3 cupcake. Well, now from the trade, the 1 donut, how much cupcake is she getting? 1/4. Well, no, that's not a good trade because 1/4 of a cupcake is tinier, a smaller fraction than 1/3. Erica shouldn't be trading if that's her deal. She could just produce the donut and cupcakes herself, in which case she would be getting a slightly larger amount of cupcakes, 1/3 as opposed to 1/4. Hopefully that makes sense. So does Erica like that trade? No. And it's not asking you to explain. Now remember how I told you to do it. If they're asking for what are acceptable terms of trade where both like it, well, again, it gave you the 1 cupcake. So I would look initially at the cupcake, 1 cupcake, and I would just circle a number in between the absolute advantages or the comparative advantages. So 2 and 3 are the numbers in between. A fair term of trades might be 1 cupcake for 2.5 donuts. Both would be mutually beneficial from that trade. Now, since it's 1 cupcake for 4 donuts, and we know that 4, the number 4, is outside that range, 2 to 3, then it's not a good trade. It's not going to be mutually beneficial. One person will really like the trade, in this case, John. One person will really not like it, in this case, it's Erica. Good with that. The terms of trade are a little challenging, but if you do it where you're converting to a single unit of the given goods that you're trading for and then comparing whether or not you should trade for it from whether you produce more of it yourself or are you getting more from trade, that's a good way to look for it. A fail-safe, especially if they talk about terms of trade, is comparing whether the number is inside the 2 opportunity costs for that given product, in this case, cupcakes, right? 2 and 3, 4 is outside it, so it's not going to be acceptable for both. It will only be good for one person, in which case the other person will not like it. So that was C. D, assume that Erica discovers a new cupcake production technique that will increase her daily production of cupcakes only. Using donuts on the horizontal axis, draw a correctly labeled production possibilities curve for Erica before and after technology change. So I'm looking at Erica. Erica can produce donuts and she can produce cupcakes. Well, if Erica did it solely by herself, you can't really see that. If Erica did it by herself, how many donuts could she have made previously? 150. How many cupcakes? 50. Great. And that was her production possibilities curve. So that's what it was initially in labeling the axes. Assume that Erica discovers a new cupcake recipe. Well, now she can't produce any more donuts. She can't produce more than 150, but she can produce more cupcakes. It doesn't give you a specific number. You can either create a number, 200, 150, anything like that, or just an axis that shows her production of cupcakes has increased from it. And I would say label something like before, after tech, after cupcake tech. Hopefully that helps. I know it's been a while. That was 2016, number 3. You may see a comparative advantage. It's fair game. All right. Adios. Hope it helped. Talk to you guys later.